This is lesson 10 and it is calculating pressure. So pressure is force over area. And we write F over A. That's just it again, pressure is force over area. And pressure is measured in either, we know force is measured in newtons and area is in metres squared, so it's either newtons per metre squared, or if it's measured in newtons per metre squared, we give it another name, and that's pascals, which is a capital P and a small a. Now, I've got an example here, and I'm just going to go through it. This is an example of a block, and it has got a weight of 16 newtons, so that's its force. That's the force it exerts on the table. So what I'm going to do is I'm going to calculate how much pressure it exerts on the desk when it's sitting on area A. So for area A, pressure is force over area. So its force is its weight, which is 60. The area that it's sitting on the table is 4 times 3. And 4 times 3 is 12. And 60 over 12 gives you 5 newtons per metre squared, or pascals. Okay, so if we then took that block and we tipped it over so that it was lying on this face here, B, I'm going to calculate the pressure it exerts on the desk. So this is a bigger face. It has an area of 3 times 5 this time. So pressure is force over area. The force on the desk is still 60 newtons because the weight hasn't changed. But when we tip it over on this side, then 3 times 5 is going to give you 15. And therefore 60 divided by 15 gives you 4 newtons per metre squared. The last one, which is C, which would be this one here. If I just show you that one there. C is this one that's sitting facing us. And C has an area of 4 times 5, which is 20. So pressure is force over area. And that's 60 divided by 20. And that gives you an answer of 3 newtons per metre squared. So what I want you to see there is that the largest area, which is this one here, the one with the 20, the side C, gives you the smallest pressure. So the largest area gives you the smallest pressure. So if you want to apply a lot of pressure on something, you make sure that the area that's in contact with that object is very, very small. Now, if you have a wee look then at increasing pressure, these are some examples. We increase the amount of pressure we use when we use a sharp knife. So if you use a certain amount of force, but your knife is really, really sharp, then you've got a small area. And since pressure is force over area, and you have a small area, you'll get a big pressure, a big answer. Second one is a cheese slice. You may have seen one of these in a supermarket. Behind the deli counter, you might see somebody using a cheese slice, and a cheese slice is a very effective way, even though it's not a sharp object, it's a very, very effective way of cutting something like cheese, a hard object like cheese. And the reason is because, again, it's got a very, very small area. And when you apply force down the way on your wire there, the wire cuts very easily through the cheese because that exerts a big pressure on the cheese. Third one there is a sewing needle, and the sewing needle, you're exerting force on your needle. And whenever you exert force on your needle has got a very small tip, so it's got a very small area. And therefore, again, if you have a small area, that exerts a big pressure. And the same, of course, applies for a drawing pin when you're pushing it into the wall. In fact, a drawing pin, if I draw one here, would have a very small area here, but a large area here. So the small area is so that you exert a big pressure in the wall, but the large area here is so that when you put your thumb on it, then it's not exerting a large pressure on your thumb because the area is big. The pressure on your thumb is going to be small, and then that doesn't hurt your thumb. And the last slide here is on how would you decrease pressure. And so these are just a couple of pictures of how you might try and decrease the amount of pressure in certain situations. If you were travelling on ice or travelling on snow, You don't obviously want to put a lot of pressure in because you'll sink into the snow, or you may break the ice if you're going across ice. So this is an example of a snowmobile, and you can see here the area in contact with the snow. They're not wheels, which would have a small area in contact, but they're actually blades. And those blades are fairly wide, and so they've got a big surface area, and therefore that exerts a low or small pressure on the snow, and it doesn't sink in. Same with tractors, which are travelling usually on very wet or muddy ground. If you don't want your tractor wheels to move into the ground or press down with a lot of pressure, then what you do is you widen the surface area. And so you can see this one here is possibly, I'm not sure what it's on here, but it's got two huge wheels at the back, big wide surface area. And that means that there's not as much pressure on the ground, and it's less likely to sink into the ground. The third one is an example which is probably maybe a bit old-fashioned by now, but these are snowshoes, and it used to be when people were going out in the snow into very deep snow, they would put their shoes in here and strap them to their feet. And what they did was they have a wide surface area, so a large surface area, and that means there's a small pressure on the snow, and it means they're not likely to sink into the snow. And the same would be true if you can adjust the amount of pressure you put on anything by changing the surface area of your body which is in contact with it. So for example, if you were out on ice and you thought the ice was going to break, if you lay down or if you try to move, sliding across the ice on your stomach or something, you have increased the surface area in contact with the ice, and you're putting much less pressure on it, and therefore the ice is less likely to break.